Okay, so you have your first law, right? Let's see how we did. How did you do on your first law? Well, what crosses the boundary? I've got, now we can take our time. I don't have to rush as much here because we started a new video. I've got heat loss. I've got a power output. This is a steady flow control volume, or steady state as this text likes to call it. I've got mass in and mass out through a single inlet, single outlet, so it's just one m dot. I'm going to have an enthalpy change, so H1 minus H2. And they've given me a kinetic energy change. So I don't have to I don't have to compute my V's, but the fact they gave them to me, I need to consider them. And the fact that it's flowing steady, that's equal to 0. Guys, you really need to be able to write this equation quickly. This is exam 2 material. We're working on exam 3 now, so you need, if you did not get this right, go back and practice lots and lots and lots and lots and lots and lots of problems, setting up this equation correctly for every problem you can find, and then check it against an online resource, check it against a solutions manual, send me an email, take me a picture and send me an email and say, hey, can you check the first law on these 5 problems? I'll be happy to do that, okay? But you've got to be good at this. This has to go quickly, because this is garbage if you can't do this correct, okay? Now, this is not completely simplified, right? Does this help us yet? Well, I don't know. What are we trying to do? We're trying to find this, okay? We're trying to find the entropy generated. To get that, we said, well, we think we can find properties. I know the temperature of the surface. That means I need the net heat in. Well, I've got heat out here. Does that help me? Yeah, that's actually kind of what we're after here. So I think we can set the tablet aside now. We've got the problem. So let's set this over here. By the way, do these help us? Do the K ratios help us? What were the conditions for a K ratio when they're helpful? Do we have those conditions? No, it's not an ideal gas, and it's not isentropic. How do I know it's not isentropic? Because you're losing heat. So it's not isentropic. Okay. Well, actually, it could be losing heat and still be isentropic, but that's a special case, and let's not talk about that. Let's try to find the entropy generated for this guy. Okay. So if we continue on with our first law, let's simplify this down. What do I know here? I do know the work per unit mass. I think I can find my enthalpies, and I'm given the speed. So I think the heat is my only unknown here, except for m dot. I don't know m dot, but I don't think I need it, because they wanted to know what is the entropy generated per unit mass, and they've given me the power per unit mass, or the work per unit mass. So I think if I take this expression here, so let me put this up here. If I take this expression here and divide everything by m dot, work per unit mass, let's say that work the problem per unit mass. What does that mean? We're just going to divide everything by m dot. So this is minus q out minus little w out plus h1 minus h2 plus v1 squared minus v2 squared over 2. That's still equal to 0. So basically I've divided the whole thing by m dot. 0 divided by m dot is still 0, because m dot is not 0. How do I know m dot's not 0? Because I've got speed. You're not going to have speed if you don't have m dot. Okay, it just wouldn't make sense to not have m dot. So we'll keep the mathematicians happy and say 0 divided by m dot is still 0. What are we trying to do? We're trying to find Q net in. I've got Q out here. Okay, so I can solve for Q out. That means Q out is equal to, I just moved this over to the other side of the equation. Okay, so this is going to be H1 minus H2 plus V1 squared minus V2 squared over 2 minus little w out, and that equals Q out. I don't know if that helps us or not. Maybe that doesn't help us. Maybe we should have left the negative sign on. Anyway, now here's what, to go into the second law, I need Q net in. Right? So Q net in is equal to the difference between Q in and Q out. Right? Well, I don't have, if I'm looking for Q out, I probably don't have any Q in, so Q net in is equal to minus Q out. Okay? And so my S gen, then, what I'm actually, the problem wants to know what is the entropy generated. S gen is going to equal S2 minus S1. I'm going to move this over, so this is minus Q net in over the temperature of the surface. Because again, I've got heat transfer occurring at a constant temperature. And this is going to equal S2 minus S1 minus, and if I plug in minus Q out in here, so it's minus a negative Q out over temperature surface. So you actually end up adding this term, right? That's kind of cool. You actually end up adding this term. So S gen is equal to S2 minus S1 plus this Q out over T surface. And I find Q out using the first law. I know all these quantities, or at least I can go find H's and I can go find S's. All right, so now I'm just down to, so here I've got, this is equation 1, this is equation 2. Right? Use this to find Q out. So now I just need properties. By the way, if you do all this, you're going to get, the way I would grade this, I would probably go out of 15 points, out of 25. If this is a 25-point test problem, I'm gonna probably give you 8 points for correctly simplifying the second law, 7 points for correctly simplifying the first law. If you get all the way here and show me this, you're going to use this and this together. You're pushing 20 points, if not really, really close to 20 points. I might get you all the way to 20 points for what's written down here. Okay, that's a B on the problem. Show me you know how to get these properties. Right? You're going to use P1 and T1 to go find H1 and S1. Right? And then you're going to use, they've given you T2 and the fact that it's saturated vapor. They said it's 100% in the vapor phase. I just write that as X2 is equal to 1, meaning it's 100% vapor saturated. Use that to find H2 and S2. I mean, just writing this down is going to get you a point or two. You're at 22 points before you've even done any calculations. That's the way I grade, like it or love it. And you show me you know how to solve the problem. Okay. At this point, you're just wrestling with algebra and units, okay, to get to a final answer. And that's why I would try really hard to get you to, I would make sure I got you to a B at this point in terms of grading scale, and I would try really hard to get you to an A at this point. Actually go get these properties, and you're going to be very close to an A. Okay. I don't know if we have to interpolate these. We can go look these up. This is exam 1 stuff. Finding these properties is exam 1 stuff. So I'm going to assume you know how to do that. Okay. If you don't, by the way, last day to withdrawal has been extended to Friday. So if you don't know how to find these, last day to withdrawal is Friday. You probably should get out, honestly. But feel free. I'm happy to help you. But if you waited this long for me to help you figure out how to find properties, last day to withdrawal is Friday. You might consider that. Questions for me? Leave me a comment. Send me an email. Find me in the chat room. If I don't hear from you, I have to assume things are going well for you. Okay. So if things are not going well for me, please let me know, and I'll try to find every way I can to help you out. Okay. All right, guys. Stay healthy. Wash your hands. Stay away from each. Practice social distancing. Exam 3 is coming up next week, so I'll put an update announcement out and put all that stuff out. But we've had, this is all the theory. This is not unreasonable for an exam 3 type of problem. Honestly, this would be on par for an exam 3 type of problem. Okay. All right, guys. Stay safe out there.